Hello and welcome to Physical Science with Ms. Wisbon. Today's lesson will be on classifying matter. This is part of our Matter Matters unit number 1, and today we're going to be looking at the concepts of how matter is classified and then actually classifying matter into pure substances, those being elements or compounds, and mixtures, either homogeneous or heterogeneous mixtures. Today's objectives follow the NC standards for physical science. So we're looking at the standards for understanding types and properties along with structure of matter. By the end of this lesson, students will be able to classify matter as pure substances or mixtures, classify substances as elements or compounds, and then classify mixtures as being homogeneous or heterogeneous. Along with this video lesson, you will have a worksheet, a note sheet to fill out, as you can see here, titled Classifying Matter, following along with the PowerPoint today. So let's get started. How can matter be classified? So matter can be classified by its state, whether it comes in a solid, liquid, or gas state, by its color, and by its uses. So for example, foods, we eat them. Shoes, we use them to walk. A spoon, fork, knife, we use them to eat our food. So those are utensils as to how we are going to eat our food. So there are other properties that we can also use to classify matter, but we're going to classify matter according to its composition and distribution of particles. How are the particles spread out in that piece of matter? So let's take a look at pure substances. Pure substances are made up of the same type of particles. So the same type of particle throughout the entire substance. So if we look at some examples, one particle, the rest are all of the same. Again, one particle, the rest are all of the same types of particles. You do have some that are bonded together, but we'll talk about these. These are called diatomic molecules. They're still the same type of particle, same type of atom. And then here you have one molecule or one particle, and the rest in that substance being made up of the same types of particles. So 3 examples of pure substances. So let's take a look at elements. These fall under the category of being pure substances because elements are made up of the same particles called atoms. Most elements are made up of all of the same individual atoms. For example, we have gold, Au, made up of the same individual element. Another one being nickel, again, made up of the same individual elements. 7 elements exist in pairs in our natural world. These 7 elements are called diatomic molecules. Di prefix for 2, atomic meaning atoms, so 2 atoms. Each diatomic molecule is 2 of the same atoms bonded together. So those 7 naturally occurring diatomic molecules: H2, hydrogen, O2, oxygen, Br2, bromine, F2, fluorine, I2, iodine, N2, nitrogen, and Cl2, chlorine. Each of these 7 diatomic molecules are found in our universe in pairs. Just the way they are naturally found, they are more stable that way. And so you will always find them in pairs. Even though there are 2 atoms bonded together, they're still considered elements, still considered pure substances because it's the same element bonded together. So H2 hydrogen gas, pure substances, all H2 hydrogen gas. O2 oxygen gas, again, pure substance, all O2, same atoms, same elements. So elements are listed on what we call the periodic table. And they are grouped by their characteristics, which we can see here. So we've got hydrogen, we've got alkali metals, alkali earths. We'll get into these later. But this is the periodic table of elements. So there are 90 plus elements listed here. All of these being pure substances. So just a few examples. Platinum, iodine, sodium, manganese, chlorine, and mercury. Just to name a small few. So if it's not an element, it could be a compound. These are made up of the same particles called molecules. So each molecule is made up of 2 or more different atoms. So we get some different elements in here. So here we have some examples. We've got water, carbon dioxide, hydrogen peroxide, carbon monoxide. These are all molecules that are made up of 2 or more different atoms, but they are combined in fixed proportions. So you're always going to find water, and it's always going to be H2O, that fixed proportion. Water is always going to be H2O. If it's not H2O, let's say it's H2O2. H2O2, there you go, hydrogen peroxide. Always going to be combined in those fixed proportions. Now let's take a look at carbon and oxygen. If you have carbon dioxide, CO2, it's carbon dioxide. If you only have CO, it's not the same. It's carbon monoxide. So it's a different compound. Compounds are always going to be found in those fixed proportions. Some examples of common compounds that we find: methane gas, CH4, again, always going to be CH4. Ammonia, this is one we use to clean, so NH3. We've got glucose here. This is a naturally occurring sugar found in our food that we use to make energy in our body. That is always going to be C6H12O6. Propane gas, this is the gas we use to grill our steaks on the grill. And lastly, another example would be benzene, C6H6. Again, these compounds are always going to be found in these fixed proportions. Mixtures. So if we are not dealing with a pure substance being made up of the same type of atom or molecule, we are dealing with mixtures. So a mixture is made up of 2 or more different types of particles or substances. Here's some examples of what mixtures could look like. You can see they don't have the uniform distribution in all of them. Some of them do. This one kind of. This one for sure, yellow, blue, yellow, blue. This one doesn't. So there's some different types of mixtures that we're going to talk about, and it's going to be on how they are, how the atoms are distributed within that mixture. Okay. So the 2 types of mixtures, main types, homogeneous mixtures. These are ones where the particles are uniformly distributed and blended to appear as though it's an even, consistent solution. And then we have heterogeneous mixtures. And these are made up of different particles that don't blend and they are not uniformly distributed. So you can see over here with homogeneous mixtures, we got a nice pattern. Yellow, blue, we got green, blue, red. And then over here on the heterogeneous side, you don't really have the same pattern. It's a little bit more random. They're not uniformly distributed. So let's take a closer look at homogeneous mixtures. And most of you know homo is the prefix meaning the same. So these are going to be mixtures that look the same throughout. They mix evenly. And they appear as though they are one visible phase. So homogeneous mixtures are also called solutions. So here's some examples of some solutions that would fall in the category of being a homogeneous mixture. Wine, salt water, so there's salt dissolved in there. You can't see it. It looks as one fluid visible phase. Same with tea. Tea in there is dissolved in the water. And then air. This is one that we don't commonly think of as being a solution, but it is. Air is made up of oxygen gas, carbon dioxide, carbon monoxide, nitrogen, argon, all these mixtures of gases, but it looks as one fluid substance. An example of another homogeneous mixture would be an alloy, and these are going to be mixtures of metals. So gold, stainless steel, brass, and bronze. They are mixtures of different molecules, but they are evenly distributed throughout, looking as one consistent, even substance. So these are called alloys, homogeneous mixtures of metals, because they are specifically metals. They have their own name. We call them alloys. Moving on, so homogeneous mixtures are smooth, evenly distributed, whereas heterogeneous mixtures are not. They are made up of different elements, different molecules, but they are not evenly or uniformly distributed. So you can see the different parts that make up a heterogeneous mixture. And just like I said, homo is the prefix that means the same, and those look the same throughout. Hetero is a prefix that means different, so you can see the different parts. So these different particles are so large that they don't evenly mix with one another. Salt and pepper being an example, you can see salt, you can see the pepper. They are not chemically able to mix with one another, so they're always going to be separate entities within the mixture. They're always going to have salt, they're always going to have pepper. Another example being oil and water. Oil always is going to sit on top of water because it's less dense, it has different properties, they can't chemically combine. So you'll see the two different parts making it a heterogeneous mixture. However, you do have some heterogeneous mixtures that will appear as though they are evenly mixed, even though they are not. Given time to sit, they will separate. An example being paint, which is why paint has to be stirred before you use it to make sure that the mixture is evenly mixed, and you have to stir periodically throughout because it will settle. So here are some examples of heterogeneous mixtures. So laundry paint, salad, sand, shots, tomato juice, and blood. And like I said, there are some mixtures that may look as though they are uniformly mixed, but given time they will settle. And so tomato juice and blood being one of those, if you give those time, they will settle. The solid pieces will fall to the bottom due to gravity. Right, so here is our review. This is our recap. So matter, again, has mass, has volume. We can categorize it into being either pure substances or mixtures. If it is a pure substance, it's going to be an element or a compound. Elements being made up of the same particles. Compounds having two or more different atoms combined, but still those fixed proportions. So you've got those different molecules. Mixtures, you're going to have two or more different particles mixing together, the heterogeneous and homogeneous mixtures. Homo looking the same throughout, homogeneous having the uniform distribution and blend, and heterogeneous not mixing, not blending, not having that uniform distribution, seeing the different parts. So hopefully today in this lesson you have a better understanding of some different properties of matter and how we can categorize them based on size, shape, texture, what state it comes in, and then how they are mixed together. If you missed anything in this video, I know the examples aren't shown in this table, feel free to go back, pause, play as you need to get what you may have missed. Thanks guys, we'll see you all tomorrow. Have a great evening.